All right, a couple things here to finish talking about. Okay, the first is this idea of arcs, which again are portions of the circumference. Okay, when you're dealing with arcs, there's three different ways that arcs will be classified. Okay, regardless of how they're classified, an arc has either a length or a measure. We're going to talk about the measures in this section. Okay, and the measure of an arc is exactly equal to the measure of its corresponding central angle. And so let's talk about the terminology here. A central angle is an angle whose center is whose vertex is the center of a circle. Okay, so in this particular case, our central angle is any angle with vertex A. So we're looking at angle BAC, angle CAD, angle BAD, and even reflex angles, angle BAC, again in that beyond 180 degree rotation. Okay, and the relationship that exists between arc measures and central angles is that central angle is equal to the measure of an arc. Okay, so what this means is when you look at angle BAC, this arc BC has the exact same measure. So arc BC is also going to be 40 degrees. Okay, now, depending on what your arc measure is, will decide how it's named and how it's classified. And so the first is minor arcs. Minor arcs are arcs whose measures are less than 180 degrees. Okay, so an arc like BC here would be considered a minor arc. Okay, when you name a minor arc, you're going to name it using 2 points. With an arc symbol above it. Okay, and so the way that would be identified is this measure of arc BC. And because an arc is equivalent to its central angle measure, okay, this this arc BC will have the same measure as its central angle, 40 degrees. And actually, let me come back here and let me expand on this. It's the measure of its intercepted arc. I want to expand on that definition. So the intercepted arc is just a portion of an arc in the interior of an angle. Okay, so when you have your central angle, there's going to be a portion of that arc that's in the interior of that angle. That is your intercepted arc. And that's going to be what the measure of its central angle is equivalent to. Okay, so what would be the measure of arc CD? What would that equal? 140, right? So you have this angle, BAC is 40, its linear pair would be 140, therefore this corresponding intercepted arc will also be 140. Okay, so anytime you have a minor arc, as long as that's less than 180 degrees, you can name it with 2 endpoints, the 2 endpoints of that arc with the symbol over the top. And now, if you have arcs whose measures extend beyond 180 degrees, these are called major arcs. You name a major arc with 3 points. Okay, they're going to start with the two endpoints of the arc. Plus one additional point along the arc. And then you're still going to have that arc symbol above it. Okay, so here, if you looked at, instead of arc CD, if we wanted basically the reflex angle, the arc that is equivalent to the reflex angle from C all the way along this arc back to D, but in the other direction. And now we're talking about a major arc instead of a minor arc. And so when you name this, you would name it with the same endpoints, C and D. However, you need to pick one other point that is contained on this arc as you travel from those between the endpoints. So B or E, either one of those is fine. So if we wanted to measure that arc, CBD, what would its measure be? So 220, we have 180 degrees from D to B, plus an additional 40 degrees to give you the 220. All right, the last case is a set of arcs whose measure is exactly 180 degrees. And these are called semicircles. They're also named with 3 points. Once again, the two endpoints, they wind up being the endpoints of the diameter. Plus one additional point along the arc. And you still have the arc symbol above it. Okay, so when we name our semicircles, when we take the endpoints of our diameter, so here our diameter is BD. So if we take the endpoints of our diameter, and we name our semicircle, we have to begin and end with those endpoints, then choose one point that falls in between along the path. So here, anytime you're dealing with semicircle, it splits a circle into two halves. In order to choose which half you use, you need to find that other point. So that's why you need 3 points. Here we're looking at arc BED, the left semicircle. We could also be using BCD, the right semicircle. So in each of these cases, if we find the arc measures, they're 180 degrees. But we would name them differently because they are different halves of that circle. Okay. It would be 220, because it's 180 degrees here, plus an additional 40. Oh, you're saying CDB. That's what you saw, right? So if you wanted to take CDB, so remember the endpoints of your arc are always the first and last letter. So if we took C to B and it passed through D, so it's this whole thing. And now it's going to be 360 minus the 40. So now it'll be that 320.